Hello everyone, welcome back to the shop. Today we'll be making part 2 of the 3 Dagger series I'm doing for the How to Forge series. And in this case we're doing a wide-bladed, fulled dagger. If you want to see the part 1, I will link it in the description below and also in the video here. Now, because this material was previously distally tapered during a forging of a previous project, I can go straight into forging the point. And in previous episodes I have described how to forge the point in. You take the corners in at a 45 or roughly 45 degree angle to make them quite obtuse, and then we start working that taper back. And this avoids fish mouthing and any kind of wrinkling at the tip, though of course we've got to make sure that we dress that thickness. And if you do end up with any fish mouthing, in the previous dagger video that I've done, you can see how to fix that in the event that it does happen. But once we've got our point established, this is quite a wide cutting blade. It's actually going to be about 2 1/4 to 2 3/8 inch wide. So the bar is already at the width it needs to be in order for it to be fulled and then drawn out the bevels. So we've got to be sure, especially when you're forging in fullers, that your bar is narrow enough that when you forge the fullers and then the bevels in, that it is going to be the final width. If it starts out too wide, the fullering and beveling is going to make it much, much too wide. So always go a little narrower than you think you need. And much like with the first dagger, we're working with relatively thick material. This blade stock tapers from 8mm at where the tang shoulders are going to be, down to about 4mm at where the tip will be. And that is basically the minimum that I would do for even a wide, thin cutting dagger like this. Now, as we're moving this tip down the blade, you'll notice that it is a little asymmetrical. That doesn't matter as long as the blade thickness is even and the blade width narrows in an even taper. Then it doesn't matter if the point's off to one side or the other. We can always fix that by bending the tip down or up, depending on which direction you decide is up in later stages. At the moment, we're just trying to establish that distal taper and the width taper, the main taper. And that is denoted by how wide we want the blade in the end. Now I'm doing quite a wide fuller. The fullering radius I'll be using is about 40mm or just over 1.5 inches. And so therefore it's going to make quite a wide blade, because it's the narrower the fuller, the less material is going to push outwards. I'm sorry, the framing of the camera is a little bad here, but you can see, hopefully, that I'm using the edge of the hammer to just draw out that distal taper a little bit more, because obviously we upset material in there when we were drawing the point down. Okay, so because, as I said, the distal taper has already been worked into this billet, I'm going to use the edge of the anvil and the edge of my hammer. Sorry for the camera movement there, but I wanted to get a better angle. Edge of my hammer and the edge of the anvil to cut those tang shoulders in. And remember, we're not trying to create very deep tang shoulders here. We want to just create a delineation between the tang material and the blade material. Again, this isn't going to be a ricassoed blade. This is going to be a more traditional medieval style dagger, which they didn't regularly have ricassos. And I actually find them easier to forge than ricassoed blades. But once we've got that delineation, we can move the metal, make a little bit of a tang offset for later on when we cut it off of the bar to finish the tang. But this just helps us with knowing where to start and stop our bevels. And obviously we are going to bevel slightly into the tang, because those bevels are going to follow down the tang in the end. But much like the first dagger in this series, we're not going to bother forging the bevels all the way down, because we can grind them in later. Every time that you make a knife, it's really advisable, if you're going to do a ground finish, to leave a little bit more meat than you would need to actually grind to, because one miss hammer blow, or one hammer blow that goes just a little bit too deep, will be impossible to remove, and those can really damage the look of your work in the end if you don't take care. So better to have a little bit too much thickness and have to grind it off, than the opposite, where you have too little material, you can't put it back on at that stage. So all I'm going to do is just back taper the tang a little bit, make sure that those shoulders are set and that I have a good delineation between them, and then I can get on with forging the fuller, because the fuller is the first thing we want to do before forging the bevels. So I'm going to use the diagonal pin here to just help draw that material out again. If you've watched the first in the Dagger series, which I do recommend because it does show some techniques that I won't be showing in this video, then you'll know that I just draw this tang out to be slightly thinner than the blade, slightly longer than the original stock, and that's just to give me less work to do when I finally cut it off the bar. I'm not trying to get it down to final tang dimensions, because obviously that would be too thin and it would whip around a little too much. What we're just trying to do is save ourselves some work when it's off the bar, because the moment we have it in tongs, we have less control over it than when it's welded to a bar. Okay, so now we're going to start fullering, and for that I've made this spring fuller. It's just mild steel with some 4140 half round, and it's wedged, so the tang goes through the bottom of the anvil and the wedge holds it in place so it doesn't jump around. Very useful for this kind of work. The dies start out quite tight, but they will loosen up after a few blows, so better to start them tight than not. And the first establishing blows should be quite heavy. You want to make sure that you're getting them centered and aligned with the blade, so make sure you're checking after every hammer blow or two. I tend to draw the blade towards me for the first couple of heats, just to make sure that I'm getting that fuller in the right direction. The big thing to remember about fullering is that it takes forever, especially with wide fullers, because you're putting a lot of surface contact on the material, and it's not the most efficient method of putting pressure on the blade. If I was doing this normally, I would make press dies for my 24-ton press, but in this case I'm using my hand hammer to show you how it can be done at home. You could technically do this with a striker, a top fuller and a bottom fuller. If you have someone who's got pretty good coordination with the striking team, then that's probably a good way to do it if you don't have a press or power hammer. But this is the other way to do it, and it's not too hard, it just takes many heats and lots of practice. And you'll notice that my fullering is jumping a little bit all over the place, it's not even. Trust the process, it's going to look a lot uglier than it at this stage than it will at the end. So just be patient with it, make sure that you're actually forging that fuller down to the even thickness along the entire length of your blade, and you'll be fine. Now I prefer to start my fullering at the tip and move back towards the shoulders of the tang, but there is no reason you can't do it the opposite way around. There's no hard and fast rule when it comes to this. Make sure that your fullering dies, however, are nice and radiused both sideways, but obviously on the edges as well. We don't want any sharp marks in the fuller, because it's going to be hard to grind out in the event that we do make any sharp marks in the middle of that fuller. And at this stage, much like when roughing in the bevels on the previous dagger, we're going to rough in the fuller, and then we're going to come back over and do a planishing heat with the fullering dies. We're just going to make sure that it's all even. And you'll notice that as I'm going, I'm actually flipping the blade over and fullering from both sides. And the reason for that is because the fuller tool at the top is going to be making more of an impact than the fullering tool at the bottom. So if you were to only pass on one side, you may end up getting a deeper fuller on one side than the other, or, and more commonly, you don't end up getting the fullering dies exactly aligned, and so they will cause twisting in the blade. So much like when forging the bevels, forging from both sides and flipping them back and forth, you want to make sure that you're doing the same with your fullering dies to make sure that you're not getting twisting in the fullering. As we go down the blade, we're going to be making overlapping blows. So we're going to keep the fullering tool in the previously made fuller, and just shifting it half a fuller's width down as we go. And this is why it's important to have narrow fullering dies. These could be even narrower than they are, to provide more force over a smaller area, and also to be able to better aim the fullers. If you do see yourself shifting from one side to the other, you know, a thinner section of beveling material on one side than the other, then make sure you flip and just shift it over just that slightest bit in the fullering tool, and you should be able to fix it. The narrower the fuller that you're making, the easier it is to cut a fuller in, but it's also easier to screw up, because you end up, if you wander and forge a little bit off center, it's really hard to get that recentered without causing significant deformation in the blade. So while wider fullers take longer and are slightly harder to forge, they are a little bit easier on the overall effect, and also most of us don't have small wheel attachments when we first start out, so you want to use something that you can get your radius wheel in there, and most of us have got a 2-inch wheel, so a 2-inch fuller tends to be quite useful for this kind of work. And that's why you doing a quite wide cutting dagger, like a medieval style Italian cutting dagger like this one, is much better than trying to do a stiletto as your first fulled dagger. Now, to allay some mythology surrounding fullers in daggers, there is a couple of things I wanted to cover while we're here. The first of which is that they are sometimes referred to as blood grooves, and there is a myth that they are used to somehow release the blade from a wound by getting rid of the vacuum. But the fact is that the human body doesn't contain a vacuum, and there isn't really enough hydrostatic force in the body to hold a blade in, and a fuller is not going to help with that anyway. The fuller's main job is to have a lighter blade for a given width of blade, or a given, size of blade. So, if this blade that I'm making right now was to be a diamond cross-section instead of a fullered cross-section, it would end up being heavier, a lot heavier than this finished dagger will be. Forging the fuller versus grinding the fuller makes absolutely no difference in modern steels, because you're not compacting the grain, you're not actually compacting anything in the forging. This simply means that you can use a narrower piece of material to make a wide blade than if you were just grinding it in. That being said, I actually dislike forging in fullers because it's much less accurate than just grinding them in. So I will quite regularly, if I'm trying to make a fullered dagger or fullered knife of any kind, will just forge wider and grind them in later, because that's easier to do and much more accurate than forging them in. Forging them in is fun, and if you've only got narrow material, then it's a good way to widen that material, but the majority of the time you're better off grinding them in. You will get a much cleaner and much more accurate result. As we get closer to the shoulders, obviously the material is much thicker, and so the temptation will be to forge the fuller deeper. Now, while you do want to forge a little bit deeper, you don't necessarily want to forge it to the depth that the rib, the middle part of the fuller, is actually the same thickness the whole way along, because that would defeat the purpose of the distal taper. So you want the fuller to basically be as distally tapered as the blade blank was when you started. So while the fuller will look slightly deeper than at the tip, it's mainly because there's more material there. It's going to look a lot more deep at that area. But it does not want to be as thin as the area towards the tip, because otherwise in the end you will end up with a blade that doesn't flex across its entire length, which is one of the main reasons why you distally taper a blade, is so that instead of bending at one specific point, it ends up flexing across the entire length, much like a fishing rod would, where it is tapered from the reel to the tip. So now at lower heats, we can start planishing that fuller in and cleaning it up a little. It's still going to look a little rough, and that's going to be true no matter what you do. It's always going to look a little rough at this stage, but if you trust the process and if you follow the rest of this forging process, then you will actually come out with a pretty clean blade. So yeah, we just go back along, try and keep that fuller central, and just dress any of the sharp marks, any of the hard fullering lines that you may have accidentally put in there during the fullering process. Remember to keep flipping the blade back and forth, and obviously remember to forge with even amounts of pressure and get a nice clean fuller. And you can see that that fuller that I've just worked over is quite clean, and that's because I'm just going back over the lines that I've already created. You'll notice that the fuller gets narrower towards the tip, and that's because there's less material to dig into, which means that the fuller is going to be shallower, and therefore is going to be slightly narrower, and that's totally fine. That's actually a good sign that you're forging the fuller nice and evenly with the distal taper. And I'm actually running the fuller out the tip here because the thickness wants to be even all the way down, and as we forge the tip bevels in, you'll see that the fuller actually goes away from the tip. But now that we've got a relatively planished fuller, although it looks a little rough at this stage, we can move on to beveling. So we got to remove that spring puller. Just knock the wedge out and pull it out of the hardy hole. So with beveling, you could start at the tip if you wanted to, and in this case I decided to do the opposite to what I did with the last dagger and start near the shoulders. And because we've got much thicker material here, you are going to get more width out of these bevels than you will at the tip. But what we're trying to do is not to touch the central section. So again, we're using those push hammer blows, pushing into that corner, and trying to forge in towards the fuller rather than forging down from the fuller. And basically we are going to be narrowing the fuller slightly as we forge these bevels in, And that's one of the reasons why wider fullers are also a good thing, because you'll end up with a slightly narrower fuller than you originally intended anyway. But it's also going to clean the walls of that fuller up and make it a lot neater. And this is a really good way to neaten up a wavy fuller if it's kind of wandered a little bit. The forging of the bevels will really help you with that. But we're still going to be chasing an even edge thickness along the entire blade, with the distal taper being dictated by the ridge along the side of the fuller. So we're not trying to forge that ridge down, we're trying to keep that nice sharp ridge between the fuller and the bevels. Working one side after the other, working from both sides of the blade, and making sure that we're keeping everything even as we go. So we should be paying attention to making sure that our edge thickness is the same. And much like with our last dagger, we're going to be rough forging the bevels in at this stage, and then coming back and planishing them up at a lower heat later. We're also looking for even bevel width from side to side. Not even bevel width the entire length of the dagger, because that would mean that we're forging the thinner material at the tip too thin. But we do want it the same either side of the fuller at the same level on the blade. So if we're slightly narrower on one side than the other, we might need to tweak something. And this is why it pays to have that fuller nice and central when you first forge it in. So you can see here, I'm making sure to forge from both sides of the blade, and as I've covered in multiple videos in this series, you want to make sure to do that because you're preventing the corkscrewing effect that would happen if you only forge the bevels from one side. You don't always get rid of all of it, but it definitely helps negate most of it. And you'll also notice that I'm occasionally throwing the blade up on edge to forge it straight, because much like with the first dagger that I did in this build series, as you're doing that push technique of throwing the hammer in almost sideways at the bevels, it's pushing the blade away and the tip is trying to come back towards the hammer. And so therefore it pays to straighten it out a little bit if it starts to get a little too wonky, because that ends up affecting the way that the bevels and the fuller interact. So you want to keep it nice and straight if you can. as we move into the tip here, we're actually going to be trying to narrow up that fuller a little bit, so we are going to be forging towards the center a bit more. And this is so that we can create that fine medial ridge at the very tip itself. Because what we don't want is that fuller to run out the tip, and for that to be the final piece, because you'll end up not being able to grind in your bevels properly to finish up the piece. So it doesn't matter if you're forging a little bit further towards the ridge, but we still want to be forging with that pushing motion, forging with the hammer coming in at a fairly steep angle from the side to try and push those bevels back in and narrow that fuller up a little bit. Here I'm doing a bit of whack forging, just trying to get it straight again, because remember that forging technique that we were using with the push forging caused the blade to warp on us slightly. The main thing is not to heat too close to the tip, because the tip will then become asymmetrical and it's hard to correct. What we're trying to do is make the main blade straight. If the tip is out of alignment, it's better to use a wooden mallet and try and push that tip over, rather than whacking it on the anvil like I was there. But now we can use some lower heats to just true everything up, make everything straight, and make everything even. Remember, we're trying to get even thicknesses of bevel on both sides. If you notice that the fuller is slightly narrower towards the shoulders because I didn't forge the fuller as deep as I should have, I'm not too worried about it, because I will be grinding this fuller later, and that means that I can increase the depth if I want to. It was as wide as I wanted it to be at that stage, and I didn't need to forge it any more than I had to. Now we're just going to cut this blade off the bar. Pretty simple process. I'm mostly aiming to hit on the tang side of the piece, not on the hot cut itself, because that way when I cut through, I'm not going to hit the edge of the hot cut with my hammer and damage the hammer or the hot cut. You could use a specific brass hammer or copper hammer or soft face hammer of some kind to do that, but I just prefer it this way. And as I did last time, I have to move to the press to do this tang because I was running out of daylight. I always tend to film these videos at the end of the day when I've been doing a lot of forging already, so I tend to run out of time. It's a bad habit of mine. But basically this process can be done with a hammer. As you guys well know, it doesn't take a lot of kind of imagination to figure out how this could be done with a hammer. I'm just speeding up the process with the press. And as before, treating it up with the hammer. Now in this case, I've already forged in the distal taper of the tang with the press, so all I'm going to do is dress out a lot of that lumpiness from the drawing dies And I could move the bevels from the blade into the tang, but again, I can grind those in as well, so I'm going to save myself some time and heartache by just leaving that tang wide enough that I can do that later. We did develop a little bit of twist, and I showed you how to correct that in the previous Dagger video, but this is another way to correct it. It's not as reliable as the other method I showed, but it is useful for when you have a really big twist, or a twist in a very specific location. This takes a very little time, it is very easy to do, you just need to make sure that you're moving slowly and carefully, and use a low heat, not a very high heat, because otherwise you'll overbend. And here's the finished product. Now, it does still need a little bit of straightening. As I said, I did run out of time filming this, so I will have to go back and give it a bit of a straighten, but that's no big deal. As you can see, the fuller is completely forged in, bevels are forged in, it's ready to grind. Basically, you could just take the scale off and you're ready to heat treat. Hopefully, you enjoyed this video, and if you did, I would appreciate it if you hit that like button. If you want to see more videos like this, including educational and build content, make sure to hit that subscribe button and hit the notification bell to be notified when I upload new videos. I'd like to say a personal thank you to my patrons, including my top patron, Jared Russell, for supporting this channel and making this kind of content possible, including the quality of the content, the quality of this audio, is all thanks to my patrons. If you want to join my Patreon crew, the link will be down in the description below and also in the card at the end of the video. With that being said, I hope you all have a fantastic day. Get out to your workshop and make something. Be safe. And I'll see you next time. Bye-bye.